right, we mentioned this the other day, so we're gonna do it again today. So today's lesson is gonna be fairly easy. All right, all we're looking at is numbers that are perfect squares and numbers that are perfect cubes. Okay, so give me an example of a number that is a perfect square. 8 is? 64.
36.
How many? 36. 4, 9, 64 is 8.
25? No.
Okay, what is a perfect square then? 25 is as well. What is a perfect square?
When you
Do what? Right. So, I'm going to come back to you in a second. Perfect squares, so I'm starting from the smallest. Smallest perfect square is what? 1 is actually, right? 1 times 1. 4, 9, 16, 25, 36, 49, right? So those are all numbers that are perfect squares. And we're okay with that. We know what the ones are. When you go 1 squared, 2 squared, 3 squared, up to probably about 10 squared, right? Maybe 11 squared. Okay, so how do I find out if it's not a perfect square or if it is a perfect square? Well, they use a method called prime factorization. So it looks something like this. I'll start with a very small one. 4. So I want to find the prime factors of 4. So let's talk about what a prime factor is. What is a prime number? Does anybody know what a prime number is? Angus?
Isn't it only be divided by itself and something else?
1.
Well, 1.
You're right. Okay, so a prime number is any number that can only be divisible by itself in 1. So what's the smallest prime number?
1.
1 isn't. 2. 2 is. And then 3, 5, 7, 11. So they can only be divisible by itself in 1, right? Reason 1 isn't because 1 is only divisible by 1. Yes, it's itself, but it's the same number, right? So 2 is the smallest prime number. Okay, so I'm going to break this down then. So how do I know it's a perfect square? Because I have 2 2's. Because 2 squared will give me what 4 is. Right? So how can I use this method for a larger number? For example, 64. Okay? So let's break it down into its prime factors.
8 times 8.
8 times 8. Okay, well that worked out well. So we know it's a perfect square, right? Fair enough? Okay, so 8 times 8. So 8 squared would give us 64. Great. Okay? Now that gets me to the next question. Back to what Kelly said. 8 is a perfect square. 8 is not a perfect square. However, it's a perfect cube, which means what?
2 times 2 times 2.
Means that I have one number that I multiply by itself 3 times. It gives me that number. So if I were to break this down, 2 times 2 times 2, that means that 8 is actually a perfect cube. And if I were to look at this further, what do you notice? 64 is actually 2 to the 6th. Okay? So this is called prime factorization. What they're going to do is they're going to ask you, okay, find out what numbers are perfect squares and what numbers are perfect cubes. So starting with 256. I want to put it in the middle of my screen here. Okay, so 256. Okay, so the first method would be to guess and check. Is there a number that I can go, I'm going to check and see if it's a perfect square. Okay, so this one takes a little bit more work for you. Does anybody know what 13 squared is?
169.
169, very good. Okay, how about 14 squared?
196.
Awesome. 15 squared?
229.
25. What about 16 squared?
256.
The calculator out of your hand.
What calculator?
256. Yeah. You can guess and check right now. No calculators. I'm not going to use calculators in this section. Okay? We're going to guess and check them. So 16 words. All right? Let's say I didn't know that. Give me one number that I do know that goes into 256 right now.
2.
2 does, sure. I always start with 2 when you have even numbers, right? How many times does 2 go into 256?
A lot.
128.
128? Okay, can I break 2 down? No. What about 128? Okay, break down 2.
64.
64 and 2. So you want to go 2 again? 64. Alright, now what? Okay, so 5. 5. I'm at a point here where I can probably pick larger numbers, right? So instead of using 2 again, what might I use here? What did I use last time?
2.
8 and 8, right? So let's do that. So I'm going to go 8 and 8. And then I'm going to go 2, 2, and 2. And 2, 2, and 2. So how many 2s do I have total here?
1. 8.
How many?
8.
I have 8 of them, don't I? Okay, so here's the thing. If I group 4 there, right? It's 4 right there. So that's 2 groups, which means then that this is a perfect square. That's what that means, right? So how do I know? Well, I have 2 groups of 4 2's. So that's 2 to the power of 4, which is 16. This is 2 to the power of 4, which is 16, and 16 times 16 gives me 256. This is called prime factorization. You circle the number of groups that you can create. All right? And that helps you find it. Okay, it's not an ideal situation for this. I'm not a huge fan of it, but it works. Okay, so let's try another one. Let's try doing this next one. 3,375. Well, what's the first number you can tell that goes into it? 5 goes into it. All right, now we got some serious math happening here. Let's just review. This is interesting because I imagine if I gave this to my grade 12s, I bet you not many of them can do it. So I don't know how many of you are going to be able to do this. You should stand a better chance because you have done this more recent than with grade 12s. It's long division. How the heck do I do long division? It's ridiculous, isn't it? You learned that in what, grade 5?
Yeah.
And you can't remember this right now.
We got E's for it.
Yeah. And they made you stupid.
Yeah, pretty much.
Right?
I was alright.
Okay, so how does this work? Does 5 go into 3? Does 5 go into 33?
No.
Yes.
How many times?
6.
Stick the 6 up here. 6 times 5 is 30. Subtract them. Bring that guy down. How many times does 5 go into 37? 7. 7 times 5 is 35. 2. Bring that guy down. 5. 25. The remainder 0. 675. Okay. That's silly, right? Why? You got a calculator. Well, newsflash, in about a month's time, you're going to have to know that because you're going to divide polynomials, expressions, and you have to do it using long division. Okay? But then we're going to add in variables to it. So, you think this isn't useful to you because you got a calculator, you have to do long division with letters in there now and no calculators. Okay? So, that's why I'm showing you this right now. Refresh your memory. Alright, so let's go back to this bad boy. Okay, 675. What goes into 675? Sure, we'll try 5 again, right? So how many times does 5 go in? 5 goes into 6, how many times?
1.
Once. That means 5, 17, so that's 3, another 15, 25 I think, so that'd be 35. 135. Okay, let's keep going. 5 again. How many times does 5 go into 13? 2. How about 35? 7. Right? Okay, how many 5s do I have right now? 3. It's important to know that, right? Why? I'll show you in a second. 27, what does it break down to? 9 times?
3.
What is 9?
Perfect square.
So what do you Yeah, so what do you got? 9 times 3, right? Which is 3 times 3 times 3. Fair enough?
I guess so.
Okay, so the first thing I ask you, is this a perfect square?
No.
Not really sure how to tell, right? Well, here's what I have. Let me just write this right here. 5 by 3, 5 by 3, and 5 by 3. And they're all multiplied together, right?
I wouldn't say so.
Okay? 5 times 3, 5 times 3, 5 times 3, whatever. I can write it any way I want. Fact of the matter is, I have this. There's 1. There's 2. There's 3. What do I have? What is 3,375? 15 cubed. Okay? Like I said, I don't prefer this method. I don't like it. Alright, not a fan of it. But what it's doing is it's just getting you ready to be able to do questions without your calculator for cube roots and square roots. That's all it is. Okay? And as we go through, once we do all of these laws of exponents, which we're going to do tomorrow, okay? Once we do all the laws of exponents, again, all of this is leading you and guiding you towards where you need to be in a year or two. So all our laws of exponents, which we're going to do tomorrow, which you've already touched on at some point, leads you into the laws of logarithms in grade 12 pre-calculus, grade 12 applied. So it's important that we get this now and we work hard at it in grade 10, because everything I'm doing with you is going to build you so that you have more than enough skills to get through 11 and 12. Okay, and that's the whole point of this process. Fair enough? Okay, so I just broke it down until I got all prime factors. And then I circled how many groups of 3's I had. Okay, now I had 3 3's and 3 5's, but I knew that 3 3's and 3 5's was not going to give me that. Wasn't going to give me the right numbers, but I knew if I took 5 times 3 and 5 times 3 and 5 times 3, I would get the same number, which means that I have a perfect cube. All right? And yes, there are parts of this that the calculator may be used. All right, but here is the next thing I want to show you. Okay. One of the things that you want to know, okay, let's start with this guy right here. Square root 64a squared. All right, so I just finished telling you, calculator is not going to help you all the way through this. You've got to know something. Okay, what am I asking first of all? Square root 64a squared. Okay, well, let's start with this. What's the square root of 64? Sure. Why is it 8?
8 times 8 is 64.
Because 8 times 8 is 64, right? We get that. Okay, what about a squared then? What's the square root of a squared?
8.
Because 8 times a is squared. That's it, right? That's simple enough. Correct? Okay? All right, so I'm going to show you, I'm going to do this a little different now. Okay? I'm going to change that square root to an exponent. Okay? Exponent 1/2. The square root can be written as an exponent to the 1/2. How do I know that? Well, watch this. 64 can be broken down to 8 squared. Agreed? And then I got a squared and I got to the 1/2. So I have all of this to the 1/2, right? Okay, this is going to lead us into tomorrow. What do I do when I have an exponent to an exponent? What do I do with the exponents? Anybody remember? What do I do?
Combine them,
How?
adding.
No. I'll show you why in a second. What do you do? Yeah, you do. You multiply them. Okay? So, I got 8 squared to the 1/2. I got a squared to the 1/2. 2 times a half is what?
1.
It's 1. 2 times a half is 1. 8a. Okay? Now I don't need to go through all that because we're smart and we know how to do this in our head. Sure. But what happens if I ask you what the 5th root of a number is? Now it's not so easy. What is the 5th root of 32? Well, what am I asking you to find right now?
What number goes in the 32 5 times?
Yes. Yes, exactly. What am I asking you? What number do I multiply by itself 5 times to get to 32? Well, this is easy enough. Should be, because it's got to be a pretty small number, right? So what's the answer? 2? 1? No. What is it? 2. It's 2. Okay? Well, let's watch and see what happens here. All right? 32 to the 1/5 now. Right? 32, okay, is 2 times 2 times 2 times 2 times 2. It is to the 5th. To the 1/5. What do I do with those exponents? 5 times the 5th. There's my answer. So, did I need to do this? Again, probably not. Because if it works out, then the only possible solution would be 2, right? Because what's 3 times 3?
9.
Times 3 is 27. Times another 3 is not 32. Great combo answer. Okay? So it couldn't be 3. Right? So there you go. Okay? I'm just looking to see what you need, what you don't need. For the most part, everything is going to work out hunky-dory for you. I'll give you this one just as cube root 125y. This is an interesting one. Okay? Cube root 125y to the 6th. Okay? So me personally, I'm doing this. 125 to the 1/3, y to the 6th to the 1/3. Okay? Remember, I can rewrite this as a fraction exponent. Everybody understand that? It's for everything. Square root is a half, cube root is a third, 4th root is a quarter, 5th root is a fifth, and so on. Okay? So it's simple, right? All right. 125 to 1/3. Can I break 125 down? What does it break down to?
5.
5 times what?
25.
5 times 25? What's 25 break down to?
5 times 5.
So what do I end up with?
5 cubed.
5 cubed. Very good, Marshall. 5 cubed. And you did it the right way. Right? You did it the right way. 5 times 25 is 125. 25 is 5 times 5, so that's 5 times 5 times 5. Okay, that's exactly how you want to look at these today. Right? So I got that. Y to the 6th to the 1/3. I'm just going to leave it as it is here. And what do I have? 3 times a third is 1. It's 5. The cube root of 125 is 5. Okay? 6 times a third is what?
2.
What is it?
2.
2. The cube root of y to the 6th is y squared. Who doesn't understand that? Be honest. Good job. I'm going to show you something. Okay? Y to the 6th, right? How many y's do I have, Dawson? I have 6 of them, don't I? 1, 2, 3. And I want to know how many groups of 2's I have. Or I want to know, how do I want to do this? Yeah, how many groups of 2 do I have?
3.
So, am I right? No,
No.
no, it's not. I want to know how many groups of 3 I have because it's a third. So
That's why you get 2.
there's one group of 3. Second group of 3. Right? So a third of that is y squared. Right there. Make sense? Okay? This is the easiest way to do it with variables. Okay, and it's going to get a little bit more complicated. I'll show you one last one and then we're done. Y to the 7th. I want the cube root of y to the 7th. Okay? So, what did I just do on the last one? What was the first thing that I did?
You wrote it out?
As what?
Exponents.
Exponents. Very good. Right on. Y to the 7th to the 3rd. Right? Okay, so this one, not real sure. Okay? Because 7 doesn't, it's 7 over 3, right? Okay, so what do I do? Well, I could have done exactly what I did earlier. Y to the 7th. 1, 2, 3, 4, 5, 6, and 7. Here's a group of 3. Here's a group of 3. So how many groups of 3s do I have completely? 2. And then I'm just going to leave that guy as is. So the solution, if I do it this way, is that. Looks awkward. Y squared times the cube root of y. So what am I doing? I'm removing all of the whole number groups out of here. And if there's anything left over, I just leave it in there.
And that would be the answer.
And that's the answer. Y squared cube root y. Now, I'm going to show you, I'll show you this without using variables because I know it's tough. We're not used to variables yet. It's tough. Watch this. Back to what Callie said earlier. What is the square root of 8? Okay? What goes into 8 that is a perfect square? 2 is a perfect square? I don't think so. What is?
4.
4. Is that a perfect square? Absolutely. So what if I change this to square root of 4 times 2? I'm going to write that again. That's the way I wrote it. Square root 4 times 2. Everybody following? Which is the same as the square root of 4 times the square root of 2. Just like that. Okay? Nothing groundbreaking or anything. All I'm doing is just separating it, because I can. What is the square root of 4? That's the smallest rational number that I can have. This, ladies and gentlemen, is called a radical, and this is what we're going to be working with for the next 2 weeks. Okay? It isn't that complicated. We'll break it down so it's so simple. All right? But this is a unit that is done poorly. Okay? Because we get overwhelmed early. So we'll get back to this tomorrow. Okay? And we'll start off with the exponent rules. But this is the same as this. I couldn't get a perfect square out of 8. And I also don't want to use decimals because then that's not an exact number. If I leave it in this form right here, I have an exact number. 2 times the square root of 2 is an exact number. If I leave it as is. The moment I change it, because this is what we would call an irrational number. Non-terminating, non-repeating decimal. So it's one that goes forever, right? Okay? All right, that's all I have. So those of you that are finished your test,